Okay, so today we're going to talk more specifically about the instantaneous rate of change, which is the derivative. So on this page in your packet, draw a general curve here and label a point A and B. And we know that the average rate of change is the slope of the secant line. And the secant line connected the 2 points that are not, they could be anywhere on our graph. So if point A here is at an x value of A, I'm going to go a certain distance over to get to point B, and I'm going to call that distance h. So B is at A plus h. That's the x value of B. So this y value here is going to be, if this is our function f of x, I plug in a plus h to x, and I have just this segment then is taking away this y value, which is going to be f of a. So if we're looking for the slope of the secant line, here's that secant line going through AB, the slope would be y2 minus y1 divided by x2 minus x1. So here we'll do that here. x2 minus x1. And what happens in the denominator? These a's go away. So the average rate of change is when our points are anywhere on the curve. Now the instantaneous rate of change we talked about on 2 days ago is that it's at a point. Not between 2 points like the average, but it's at a specific point. So what happens is if we have the secant line through AB, the point B needs to be really, really, really close, or really on point A, to be the instantaneous rate of change. So instead of having the secant line like this, as I move B closer and closer and closer to A, here's this secant line. Notice how my secant lines, their slope is getting closer and closer to the slope at A, this tangent line. So remember, we just finished a unit on limits, and as we moved the point closer and closer, and getting really, really super arbitrarily close, that was the limit. So as we move this point B closer to A, if I look back at how I labeled my average rate of change picture, that means this distance of h is approaching 0. So the instantaneous rate of change is when your h approaches 0, meaning the second point B will be directly on point A. We can see an illustration of this. I'm going to go to this website here. And this graphic demonstrates the secant line moving and changing to a tangent line. So see how here's the secant line between 2 points. The point's moving closer and closer, and right there's the tangent line. So we can pause the video right when these 2 red points get close together, and you'll see that this slope of the secant line is getting really close to the slope at this point. So the derivative at a point, the derivative is the same thing as the instantaneous rate of change. we can think of that as the slope of the curve at point A and the slope of the tangent line to the curve at A, and that's this brown line that I drew here. Okay, for number 1, is the derivative of ln of x plus 1 equal to, at x equals 0, positive or negative? Justify your answer, meaning give a reason. To justify your answer, you have to write why you know why that is your answer. So the derivative, we're just going to think of that as the slope. And it's going to be the slope at x equals 0. So we're going to graph ln of x plus 1. If you have your graphing calculator, you can graph that there. It's going to look like this, approaching an asymptote at x equals -1. So at 0, which is right here, if we draw the tangent line, the tangent line just touches the graph at that specific point, what is the derivative? Okay, the derivative is the slope at 0. So is that positive or negative? We're walking along this line, it's positive, because here's the justify your answer part. The derivative is positive. The slope at x equals 0 is increasing. It's going up. It's a positive slope. That makes it a positive derivative. So if we were looking at this on our calculator, and it is a curved graph, it has a nice bend to it. If I zoom in, so see it says zooming in, if I zoom in closer and closer, that curve is eventually going to start to look linear, like it's going to be straight. So if you have your graphing calculator, if you put this in Y1, and you go to your zoom, choice 2 is zoom in. If you keep zooming in right at 0, you'll see that your graph eventually, the closer you get to, is eventually going to look like a straight line. And that's how we could calculate the derivative or the slope right at that point. Okay, we're going to turn the page. So let's look at number 4. Please draw this graph. It is the graph of 2 to the x, this exponential, and we want to estimate the values of the derivative graphically and numerically. Graphically, that's where we're going to draw the tangent line. Numerically, we're going to calculate slope. Okay, so let's draw the tangent line at x equals 0. So here's where x equals 0, so I want a line, I'm going to have to move that, where it just skims the graph at that point. Like that. So there's my tangent line. Oh, I'm sorry guys, we need to label A, B, and AC. So let's say that A is our y-intercept here, B is at -1, and C is at x equals 1. Okay, so now that we have our points drawn, let's start again totally from scratch. We want the slope of AB. This point is at 0, 1. B is at -1, 1/2, and C is at 1, 2. So to calculate the slope of AB, I'm going to find y2 minus y1 all over x2 minus x1. So that equals 1/2 divided by 1, which is 1/2. Now if we drew this secant line between the 2 points, that is a positive slope, so that matches that the slope would be a positive. Now for the secant line between AC, let's calculate the slope again. y2 minus y1 over x2 minus x1, that's 1. Now remember, our tangent line, which is the derivative, the slope of the tangent line is the derivative, that is the limit as your points C and B get closer and closer to A. So to actually estimate the derivative at 0, let's find what 1/2 and 1 is approaching. So if we think about what's in between those, that would be 3/4 or 0.75. So remember, we're still just estimating. We're not calculating the derivative yet. We can calculate the slope, which is the average rate of change, but we're estimating the instant rate of change. So we're going to use this information to answer number 5. Find an approximate equation for the tangent line. So I want to write the linear equation for this green line here. So remember, I said your best friend in calculus is going to be point slope form. Y minus y1 equals m times x minus x1. We can fill in our slope, that's our derivative at 0, which we got was 3/4. So now what we need is y1 and x1. So I need the coordinates at x equals 0. We have that here. So y1 is 1, x1 is 0. Okay, we can simplify this. Y minus 1 equals 3/4 x. Now let's add the 1 to the other side. 3/4 x plus 1. So here is the equation of our tangent line. Okay, and lastly for number 6, you have these pictures and graphs already in your packet. So the graph of f of x is shown. Indicate whether each of the following is positive, negative, and draw your answer graphically. Alright, so for A, f prime of 1, that's an instantaneous rate of change because it's the derivative. So here's our point at 1. Our x value 1 on the graph. So to draw the derivative at 1, that's the tangent line at 1. Now is the slope of this line positive or negative? It's positive. Okay, for B, if you look at the structure of how this is written, what does this look like to you as something that you would calculate? It's standing for slope. So it's the slope between x is 1 and 3. So here's 1, here's 3. So the slope, the slope of this secant line, because this is asking about the slope, is positive. Okay, for C, this is just the change in y values. So here's our y value at 4, and here's our y value at 2. So if we take the point at 4 and the y value at 2, so let's estimate, let's say that's at 3 and this one's up here at 5. What is 3 minus 5? Is that going to be positive or negative? Negative. The reason I knew B was slope is because it was the difference in y over the difference in x. Whereas in C, it's just talking about the change in y, the subtraction of the y values. Okay, two more. The average rate of change. That's talking about the secant line between 3 and 7. So what is the slope of the secant line between 3 and 7? Is that positive or negative? It's positive. And lastly for E, the instantaneous rate of change. That's the tangent line at 3. So I need a line that's going to just touch my graph at 3. It's hard to draw. And that's not very good. It's much easier to use this. So the slope of that line is negative. Okay, so now the next page in your packet is your homework. You have to do 8, 10, 11, 12, 13, 15, and 17. I expect that you're going to start that now and use the remainder of the class time to do your homework.